Today in section 8.1, we are going to be graphing what are called exponential functions. And before we do that, we're just going to kind of review through some of the parent graphs that you've seen previously, and also think about how the different rules for translating them will apply to this. So things like, shifting right or left, up or down, that kind of stuff. So first of all, y equals x is our parent graph for a line, and you'll remember that that, just passes through the origin and has a slope of 1. The second paragraph is quadratic, and I know it doesn't really look like it. My smartboard was off when I drew this, but the vertex should be there at the origin, and we've got that upward opening. The third one is our absolute value graph, and that is that V graph that we've had. Again, the vertex is at the origin. Number 4 is our root, our square root function. That's what we did in our last chapter. That was our swish and our scoop that we had graphed. Now 5 and 6 we haven't done a whole lot of, but if you think about what we had learned previously with n behaviors, y to the third, or x equals to the third, I can't even talk this morning, x to the third, there we go, is going to look like this. And actually we're going to be graphing these later on. And then x to the fourth is just going to look like our parabolas. What we are going to be concerned with today is number 7, which is y equals ab to the x. So this is an exponential function. You can see that instead of having an exponent of a 2 or a 3 or a 4, the exponent is the x. So our exponential function is going to be one of either growth, that I've indicated in this first diagram, or one of decay. And you'll use exponential growth a lot when you're dealing with science. Maybe some of you have done some of this already if you've taken chemistry. You'll also look at decay in science as well. Also banking uses a lot with exponential functions, looking at the growth of money. Okay, so moving on. We're going to talk about the rules. The basic parent graph is this right here, y equals ab to the x. Now, what we're looking at is a is a variable, b is a variable, and x is a variable. If b is greater than 1, it's going to show growth. If b falls between 0 and 1, so in other words, if it's a fraction like half, or 1/4, or 3/8, then it's going to show decay. A is the y-intercept if we don't have anything else that's being added onto this. So for instance, if we had something like a +3 out here, well then it's not the y-intercept anymore. But it would help us tell how to shift off the asymptote. If it's just our parent graph like this, if a were 2, it would tell us to shift up 2. If it was a 5, it would tell us to shift up 5. And you'll kind of see how this works as we get graphing things. Now if the absolute value of a is greater than 1, then the graph will be steeper and skinnier than the parent graph. And if the absolute value of a falls between 0 and 1, so again, if it's a fraction, less than 1, but greater than 0, it's going to be wider and less steep. And think about that with parabolas. Again, absolute value of a, if it was greater than 1, it was a skinnier parabola. And if it was a fraction, it made it, wider. Something I've got with a double asterisk there is if a is less than 0, the graph will be reflected across the y-axis. So it'll just be its mirror image. Now, this stuff starts looking kind of complicated, but I don't want you to freak out about it. If we have y equals ab to the x minus h plus k, so that means instead of just having y equals ab to the x, if we have something added or subtracted to that exponent, that h is going to indicate that horizontal transformation. So again, right or left. If you're adding k, just like with our other graphs, that's going to tell us our vertical transformation, whether we're going to move up or whether we're going to move down. Now, if k is 0, like it would be in our parent graph, the horizontal asymptote is the x-axis. Otherwise, it tells us if that horizontal asymptote is transformed. So it's going to be very important for us, if we have something added or subtracted, that we have to draw in the asymptote. If the asymptote is the x-axis, we don't have to draw it because the x-axis is already there. Okay, so now if you're sitting here thinking, okay, wow, this is a lot to digest, How am I going to remember this? The best thing for us to do right now is just to practice. All right, so example 1, we've got y equals 4 to the x, and we're not only going to graph it, but we're also going to state the domain and range. And again, we'll use our interval notation for that. What I want you to understand is that this really means y equals 1 times 4 to the x. Because remember, the form is y equals ab to the x. So what does that tell us? Well, first of all, the b is greater than 1. So we know that this is going to be a growth problem. We also can see that a is 1. So that is going to tell us how we're going to have a point up 1 on that y-axis. That's going to be our y-intercept. We don't have anything else being added or subtracted from the exponent of x, and we don't have a k that's being added. So that's going to tell us that our x-axis is going to be the asymptote. And then we are going to have, I'm just going to put a few hash marks on here. We're going to have a point up 1. Okay, that's this thing right here. And our x-axis is the asymptote, which means that our graph is going to skim along the x-axis without ever touching it. So we're going to try to get as close as we can. Now my smartboard's off a little bit, of course, as always. So whenever it's growth, remember growth is looking like this. Decay would be looking like that. So because we've got growth, we're going to skim along our x-axis, and then we're going to go up, and then we're going to climb. Okay? So that is our graph. Now our domain and range. Remember domain, we go from left to right. The range, we go from bottom to top. So domain, we can see that we've got negative infinity. And then for our upper end of our domain, we're going to have positive infinity. Because even it's going to keep climbing, but it's also going to keep going to the right. Then for our range. Now for our range, it's going to skim the x-axis without ever touching it. So to indicate that, we'll put 0. We'll have to make sure that we've got a parenthesis because it's not included. It won't ever touch that x-axis. And then for our upper end, you can see that it's climbing, and so that's going to be positive infinity. If you're ever unsure, and you're sitting here going, oh my gosh, I completely forgot what all of this means, when in doubt, you can make an XY table. So I just want to show you that real quick. So if I chose to put 0 in, if we had y equals 1 times 4 raised to the 0, well, what does any number raised to the 0 mean? Well, remember that any number to the 0 is 1. And so we'd be taking 1 times 1. And so that would give us that. And as you can see, we've got our 0.01. Then if we put, let's say, 1 in there, we'd be taking 1 times 4 to the first power. 4 to the first power is 4, so 1 times 4 would give us 4. And so if I wanted to put another point on here, see mine's a little off, I could go like this and put a point, and then I could just make this a little narrower. Okay, and so you can see that it would go like that. If you want to try one more point for good measure, you try -1. If we had 1 times 4 to the negative first power, that would mean 1 times 1/4. And at -1, you can see that we've got a point that's about 1/4. Okay, so when in doubt, you always have that XY table to fall back on. Let's look at example 2. So we've got y equals 3 times 2 to the x. So again, ask yourself, what does this mean? First of all, is it going to be growth or is it going to be decay? Well, this 2 tells us that it's going to be growth. Then we are going to take a look at our y-axis, or not our y-axis, our y-intercept. You can see that there's nothing being added on, so that means that our x-axis is the asymptote. So 3 is going to be our y-intercept. All right, so again, we'll graph this. And we'll put a point up 3. just a second here. And again, it's growth. And so we'll just kind of skim along here and up we'll go. Okay, see if you can do the domain and range. Again, the domain, we're going to go from negative infinity to infinity. The range, once again, is skimming the x-axis without touching it, so we'll be at 0 to infinity. All right, hopefully, so far this is making sense. Now I'm just going to amp it up just a titch. So in example 3, we've got y equals 5 times 3 to the x minus 2. You can see that the minus 2, that is not part of the exponent. So that means that that's at k. That's going to be shifting us vertically. So what does that all mean for us now? Okay, first of all, let's decide if this is growth or decay. You can see that the 3 is going to indicate growth. Now, if this minus 2 hadn't been there, that would have told us that the y-intercept would have been 5. But what if this is going to do is tell us, uh-oh, it's not 5 anymore. It's going to be shifted up 5 from our asymptote. This means that our asymptote is going to shift down 2. I'll put the word asymptote here. And so once we get our horizontal asymptote in, then we will move up 5 from there, and that'll be our y-intercept. Okay, so let's look at what this would be graphed like here. All right, so let's get some hash marks. All right, so we've got an asymptote that's down 2. So we need to indicate that by drawing a dashed line at negative 2. Okay, let's pretend that's right on, okay? Now we'll get our y-intercept on. So from there, we need to go up 5. So 1, 2, 3, 4, 5. So you can see it's not 0, 5, it's actually at 0, 3. And again, if you're sitting here going, oh my gosh, I don't know if I'm doing this right, well, let's just try it. Let's sub 0 in. If we were to take 5 times 3 to the 0 minus 2, that would give us 5 times 1 minus 2, which is equal to 3. So see, you can always check it. You don't have to get yourself stumped. Now when we graph this, remember that this is going to skim the asymptote, not in this case the x-axis. So if you were to draw it like this and up, I would count it wrong because the x-axis is not the asymptote. So let me undo that because I don't want it like that. Okay? Make sure that you're indicating that you're skimming the asymptote. So you're going to come along here and then you're going to go up through that point. So now what does that do to our domain and range? Well, as you can see, the domain is still going to be negative infinity to positive infinity. And this time the range, instead of being 0, it's going to be negative 2. And again, it gets the parenthesis because it's never going to touch it. And then up to positive infinity. Okay, hopefully, so far, so good. Now we're going to change it up just a little bit more. In example 4, we've got y equals 4 times 1/8 to the x plus 1. So finally, I'm giving you a problem with decay. So we know this is going to be decay. And again, we've got this plus 1. So we're shifting that asymptote. That means our asymptote is up 1. And then the 4 is going to be up 4 from that. All right, so let's draw this thing. And if you want to try this first and then check with me, this would be a great place to pause. Okay, so we're going to get our asymptote at 1. There we go. And then we are going to put our y-intercept up 4 from there. So 1, 2, 3, 4. And now this is decay. So remember, decay starts high on the left and falls as it moves to the right. And again, we're going to skim that asymptote. So we'll just kind of come down like this and then skim that guy. Okay, so it's not that bad if you just stop and look at every little piece and what it means. Domain, still going to be negative infinity to positive infinity. But this time, the range, we're going to look at, what's the low end? Well, the low end this time is 1. And then infinity. Now, sometimes people accidentally put infinity to 1 because they're looking at it from left to right. Remember, range is from bottom up. So it doesn't matter whether it's falling or it's rising. The low end is 1. The upper end is still positive infinity. All right, now if you're really feeling smart, you might want to try 5, or at least see if you can figure out what all the pieces mean. So this would be a great place to pause me, try as much of this as you can, and then check it out with my work. All right, this is about as complicated as these are going to get. So what does everything mean? First of all, this is going to be our decay. Now, look at this time. We don't just have the 1/4 raised to the x, we have the 1/4 being raised to x minus 2. What does that mean? If you recall with all of our other transformations, that actually means right 2. Remember, it's got that opposite effect. Then we are going to move the asymptote up 3. And then our y-intercept is actually going to go down 2 from the asymptote. And the negative means it's going to reflect. Ooh, so think about that. This is a lot to think about, isn't it? Okay, so one thing at a time. So first we'll get our asymptote in here. Okay, so we are going to, I'm just going to do up and down again. All right, so we are going to get that thing up 3. There we go. Now, because we have the right 2 and we've got the down 2, what that means is normally, you know, the y-intercept is going to be off of that asymptote. So we are going to, off the asymptote on the y-axis, go down 2. And then we are going to go right 2 as well. Oh yeah, I did that, didn't I? So down 2, this is the down 2, and this is the right 2. So let me just put a little red dot. This is where we'd be starting. There's not a point there. I'm going to go down 2 from there, and then we're going to go right 2. So this actually shifts it off the y-axis. All right, now it is the flip of what decay would look like. So if you're looking at this going, oh my gosh, I just don't know what this looks like when I have to make it decay and I have to reflect it across this asymptote. So what sometimes I suggest people do is think about what decay would look like. Decay would normally look like that. So then if you think, okay, now I need its mirror image. Well, that means that we're going to have this thing coming along like that, and then it's going to drop like that. And then you can just get rid of this guy right here. Try not to get rid of too much stuff. Let's see if I can do the little one here. So you can kind of use that there as a guide for yourself. These tend to be the toughest problems that we've got, the ones where you flip them over. And again, if you weren't sure, do an XY chart. Do a couple points, and then it'll give you a little bit of guidance. All right, so now our domain and range. Again, the domain, you can see, is negative infinity to infinity. But the range is different this time because we have this thing going downward into infinity. So the low end is negative infinity, and the high end is going to be 3 with the parenthesis. Okay. I think this is our last one, and again, 5 and 6 I'd say is the most complex that this is going to get. So see if you can figure out what the parts mean, and then give it your best shot and see if you can get this one graphed. All right, first of all, this is going to tell us growth. This is going to tell us the asymptote shifts down 4. And then off the asymptote, this tells us that we are going to go down 3, but left 1. Okay, so let's see what this looks like. Get this so we can see it. There we go. All right. Okay, so let's get this asymptote. Down 4. 1, 2, 3, 4. Okay. Oh yeah, and this thing's going to be reflected. Sorry, I forgot to mention that. Okay, so we're down 4. Now off of that, remember we're going to start right here on the y-axis. We are going to go down 3 and left 1. Oops, and I didn't even draw enough hash marks today. There we go. So down 3, left 1. So there we go. So again, think about what growth would look like. Growth would be skimming along here and up. And so we need its reflection. So I'm going to get rid of this first so I can just hit undo here. Do that again. And so I know that I'm going to need to skim along here and then drop down. There we go. Did your graph look like that? I hope so. Domain, negative infinity to infinity. And then our range, again, it doesn't matter that it's high at the left and low as we move right. Remember, it's from the bottom up. So we're looking at negative infinity to negative 4. I believe that's it. Let me just double check. Yep, that was it. So if you're having sort of a tough time wrapping your head around this, I would suggest going back and starting from the beginning again and seeing if, as we work from the easier problems to the more difficult problems, you can start putting pieces in place. If you still have questions, please let me know.